Okay, hello. Welcome to my presentation. Insights, how not to hurt yourself. Jak nie zrobić sobie kuku po polsku. And who am I? I'm a Java developer at Solars Consulting. Actually, currently also a tech lead in one of our product teams. I'm also a Developers Guild co-owner. So we are doing knowledge sharing inside Solars, and I'm responsible for Java part inside of it. And also I'm a fan of whatever makes our craft better, so DDD, craftsmanship, and so on. And also a video board tabletop games fan. If you know some of those, like video and tabletop, and you know what Baldur's Gate 3 is, then you know probably that, yeah, I played it. Okay, a few disclaimers at the start of presentation. So the first one, I don't know if you read the description, but this presentation will resonate best if you know Java JPA. And if not, similar mechanism may occur in other technologies. The spoiler, they are occurring in other technologies. And I will say even about some similarities or not. But at the start, I would like to ask you, who is a Java developer here? Raise your hand. Okay, a few of us. I think that, I don't know, correct me if I'm wrong, but I think that's the only presentation that had Java in the description, isn't it? Yeah. Thank you for coming, though. So who is from .NET ecosystem? Okay. Hello, guys. From Python? One, okay. And from other? Okay. And what is it? Node.js or? Yeah, okay. Thank you. We'll be talking about ORMs, but based on Java, and we'll see what mechanisms are in Java, and I will say, if I know something about other technology in the context of some mechanism, I will say it. For whom is this presentation? So I assume that you know what ORM is. Okay, I will not be diving into the basics of ORM, so what is entity and so on, and that it prepares some DDL and so on. We'll be talking about sometimes basics, but not on this level. I hope that you implemented some entities, associations, you used queries, maybe some transaction by code, and you had problems, or you were lucky enough not to have them. And disclaimer number 2, actually the third one, because we start from 0. I haven't seen all the systems issues, and I can only use my today's best knowledge. So if you see anything in that presentation that is off or something, please let me know in the feedback after the presentation. Let's grow together. Okay, so let's start about why we are talking about this topic. Because more than a half of application performance bottlenecks originate in the database. AppDynamics says it, and it's a company that does software that hands down such a bottlenecks, so they have to say it. But I think that it's not far from the truth. So let's see how not to cook yourself with ORM. And before I start pinpointing the particular pitfalls, let's say that all of us, we started something somewhere, yes? So probably when you are starting your career with some language technology, you are not reading the whole documentation, you are not watching all the talks about some technology, you are trying the hard way. So for those who were trying the hard way, maybe missed some details, this is the presentation you may base your knowledge on. Yeah, and I think that is a good depiction of developer. Okay, so in my opinion, to avoid hurting yourself with ORMs, we need to know what are entities, states, so what states entity can have, and dirty checking. Then we'll go into associations and loading. And at the end, we'll say something about transaction and locking. Okay, let's dive into the entity states and dirty checking. So for Java developers or for .NET developers who know the font, but it's not .NET, what may be off with this service? I will ask to the public, and if nothing occurs, I will say it. If someone guess, I have a duck for you. I will throw it at you. So you need to know and catch. Anyone? Do you know why we need only to set it and not save? Do you know why only we need to set and not save under the method? Or great one. Okay, so I will throw 2 ducks. Who said the second one? Okay, so for you. Yeah, great one. And yeah. We would do a good try catch blocks, yes, because I am throwing and you are catching. Okay, so yes, I will say why is that, but if you have a unit of work in Java transaction, in .NET unit of work and so on, you don't need to manually save, flash, synchronize the database state, because the entities here that we load from database are in some state, some entity state. So who had seen a picture like that in their life? 1, 2, 3, okay, 4, okay, not bad. So entities inside transactions unit of works can be in few states. So when we create a new entity, so class that we try to map to database, it's transient, and it means that the ORM doesn't know it exists. Yes, actually, after we save, persist, or merge the new class, a new object, new entity, then it's persistent, and then the ORM knows that it exists, and it can track it, it can manipulate it, it can generate SQL statements after the transaction. We can also detach the entity from the transaction, from the unit of work, and then the transaction will not know about what happens to the entity after that. And also we can remove the entity from database by calling some methods on a repository in case of Java, or a DAO, and it will then be removed after the transaction. And also, of course, garbage collection will occur after the transaction unit of work will happen. And also, that is the same diagram, but from .NET. So they are really similar. There is only one new state unchanged. So not very, I don't know, inventional. Let's go further. And how does it work in Java in case of having the entities in some states inside the transaction? So first, we start the transaction using some API. Yes, in Java, I personally use transactional, but if we want to create fine-tuned transaction, then we can use other API. Then, when we have the transaction unit of work running, we can manage the entities. So we can create them, save them, load them, change them, remove them, and we can do some operations on Java level. So some business logic, yes. Then, when we want to close the transaction, the SQL generation occurs. So from the states from the entity states, there are some statements generated. There occurs flash, so synchronization with database, commit, so the commit to database, and then the session is cleared, and no entities are in the session right now because it is closed. But where are the managed entities held? We have something like, in Java, we have persistence context. In .NET, is it like DB context? Yeah, something like that. So very similar. And what happens here? We have persistent context created for entity manager during transaction. So once we open the transaction, we have persistent context. All the entities are held there, and we track their states. Then context is first level cache. So if we want to read an entity from database inside the transaction, and we have this entity inside the persistence context, then it will load the entity from the context. So we have repeatable read, but from inside the transaction. It's very important. So if you have anything in persistent context and you want to load it from database, then it will load it from persistent context. It has downsides, but it's also very profitable. Context never forgets until the transaction ends or you make it. So we can flush and clear everything, and the transaction will end. The context will forget the entities. And once the unit of work is closed, the SQL statements are being run based on its content. So updates, inserts, and so on and so on. So that is the persistence context. And how ORM knows when an entity is changed? Do you know the keyword here? It was like on the slides before. So we are talking now about dirty checking. It's called dirty checking in Java, JPA, Hibernate areas. In .NET, from what I know, it's tracking. So it's auto-detecting the incoming changes on the entities, and we are scheduling based on that needed queries. So basically, we are having entities, and we know that what happened to them, and we generate accordingly. And when it occurs at the transaction wrap up. So I will show you something more. So the diagram of how it works. We have some managed entity in persistent context, and before it starts to be managed, so persistence, and it is in persistent context, we have a state snapshot of it held in memory. Hibernate creates that. Sorry that I'm using JPA and Hibernate interchangeably, but JPA is an interface set of standards for ORM in Java, and Hibernate is an implementation of that. So for the most of times, they share the same like mechanism and not names, but let's assume for this topic that yes. Okay, so we have state snapshots of every entity that we have in persistent context. We do some operations on entities, they are updated. And then when we want to flash, so wrap up our transaction, dirty checking occur. And then we are checking the entities updated with their snapshots from the start. And then the process continues. We are getting the SQL queries and so on. But what are the consequences of dirty checking? So here we have some method, of course, in transactional scope, and we are loading all products from database. I don't know who would like to do something like that, but okay. And then for some product IDs that are in some argument, we are changing some prices in this list. And what is interesting is that even if only one property, only one product is changed, Hibernate will still need to check all managed entities. So dirty checking is not for free. It's not free magic. Additionally, the state snapshots takes two times more space that entities would take themselves. This magic is not for free. And I would like you to remember that, because maybe fetching all the data from database is not like very intelligent, but having 2 times more space held because of that, and then the need of processing them all in the memory is significant. So that's simple math for you. Maybe you will need it in the future. So the number of dirty checks done on Flash are the sum of number of properties of given entity per entity. So if we have 10 entities and every entity has 10 fields, then we have 100 dirty checks. So let's remember that. And how to avoid the memory overhead when we are dirty checking, because we want the dirty checking. It's magic in ORM and we want it. So the first and the simplest, limit your queries. Don't fetch all the data. Yes, everything you fetch into the memory is doubled, needs to be processed. Don't do it. It's like a very simple rule. The second one, if you need the data from database only in read-only context, then fetch them into the objects that are not writable. And JPA and Hibernate supports 3 groups of projections. We have entities, and entities can be hacked by setting some flags on transactions to be only in read mode, so transaction will not commit anything to database. But I'm not a big fan of using the same model for writing and reading, so let's assume we don't like that. We have scalar projections, object arrays, and tuples, and that is better, but we don't have much metadata in it. Yes, we don't have like classes with all the fields. We have to traverse it and so on. Not the best one, maybe for some cases. Also, we have DTOs, data transfer objects. If you need something from some table, few properties from the table, please create a data transfer object with these fields and query it from the database. And it will be read-only then, because entity is writable in the context of ORM. Okay, so I hope that after this introduction, you won't be that guy. And let's go to the next one. Is it working? Yes. Okay, so we'll be talking about associations and loading. So one of the truths that I've read in one of the books that I will be recommending later on, you can write a sophisticated applications without ever mapping a collection. Do you agree? We can talk about it later on. But there is a very important thing. Make sure you actually need a collection. And I will be saying in the next slides, why is that? Why you should care about it. Okay, so how many types of associations you know? Throw a number at me. 3. Yes, 3 or 4, depends on who said that. Can I throw a duck at you? Bam. Okay, sorry. Okay, so we have 3 or 4, depends on how you count it, because you may think that many to one and one to many is like strictly related, okay? And yes, there are 3 or 4, what is the problem? But in how many ways can you program it? And there are many options. And in Java, we have like more than that, because I didn't write everything here. I think when I was searching in .NET Entity Framework documentation, I've seen more than even in Java. So there are many possibilities. But why? Okay. Why there are so many? Because we have few options. In Java, for example, we have unidirectional. I think that is universal, that we have unidirectional and bidirectional associations. So in unidirectional, you have reference only on one side of the relationship. So if you have a company and employee, so employee have a reference to company, and that's all. And it's very natural in context of database, because in database every association is modeled with a foreign key, and only one of the tables has the foreign key to the another one. But in code, we have a possibility to do a bidirectional, so both sides of association have reference to the other side. So company has a list of employees, and employee has the company. In Java, we have something like value type. I don't know if it's in the other languages, other libraries for ORM, but we have something like embeddable. They are simple, basic types. Also, the custom classes that are mapped in specific ways, and I won't be diving into details here, but don't use them as collections because they are not very performant. And let's stop at that. But why is it important how I model an association? Because ORM can do things, and everyone that tried blindly to map an association knows that. For example, let's take a look at unidirectional one-to-many. So we have list of employees. Let's assume that class is a company, yes? We have company class, we have list of employees, and it has annotation one-to-many. That's how in Java we annotate the relationships, the associations. And what would you expect is that the Hibernate JPA will treat it as, okay, we have one-to-many, so on the employee, please put the foreign key of company. But what Hibernate is going to do, it will create a join table. Why not? And it's not a big deal in case of DDL, so creating your schema, because I don't recommend using ORM for creating your schema, maybe on early development stages, but later on, please use some tool to manage your history of schemas. For example, I don't know, Liquibase or just pure SQLs. But DDL, we are not worrying about that. But once you map it this way, it will not be matching the schema, probably. So you might not want that. But what's more interesting is how the insert to the employee table will look like. And it will retrieve all records from the join table, of course, that are associated with the company, for which the employee will be created, I believe. It will add the employee to the employee table. We'll update company with new version. Version is something for optimistic locking. I will be talking about it later. And we'll insert the new connection to the join table. So such a simple join table, and Hibernate, because of that mapping, is doing very many operations. They are not necessary. If you map it well, it will be working simpler. Okay, be sure how the association you create will look like, or Git blame will find you. That's my favorite meme. Okay. Second thing, do you really need to map bidirectionally? So have one-to-many and many-to-one on associated entities. So we have company, it has list of employees. We have employee, it has a company, yes? And for example, let's assume that this list is very huge. do we need this association? Not exactly, because why would we? So because maybe the many-to-one association is enough. Maybe we don't need the list. Why do we need list? Because we want to put things there and ORM should save it. But in case of big collections, it is problematic. And I know that in .NET, lazy loading is not like a problem of daily basis because they turned it off. But in Java, we have we are emphasizing usage of lazy loading, and the usage of such a list, like on the previous screen, can trigger lazy loading by the and it can take a developer by surprise. So maybe you don't need such an association, yes? If you want to gather the list of employees of the company, maybe you just need to use query and use the foreign key of company. Why not? Also for the updates, you can generate a query. So use design to avoid pitfalls. Maybe navigation properties, they are called like this in .NET, are not necessary. Maybe. You decide. And when it comes to lazy loading, what does it even mean? I will say how it's by default in JPI Hibernate, so the main ORMs for Java. In case of one-to-many and many-to-many, they are lazy. So if we have collections, they are lazy. If we have only one element mapped, they are eager by default. The fun fact is that Hibernate didn't want to follow this until the version 5.x. They had everything by lazy, so that's a fun fact. Lazy loading means that Hibernate will only hit the database for related entities only when you use the association. So getter results are not in that case. So if you use a getter on this field, you will just get a proxy that is not loaded yet. But if you want to traverse the list and do something on the objects, then it will hit the database. So it should be a good thing, but it's often a problem. On the contrary, what does eager loading mean? Once we load the employee, we also load the company in the end. And many-to-one is by default like that, so I didn't annotate it here. Okay. In Java, fetch type lazy is suggested as a rule, but I know for various features, for various needs, we want to use the lazy or the eager. We have some needs behind that. I will say what are what is dangerous in both of the approaches. But in case of an eager, if you think that eager is okay for single object, think of the moments when you need to fetch large amount of the, for example, employees. If you have eager on the company, you will, once you are loading the 1,000 of employee, you are loading 1,000 of company. Think of that situations, and also the entity can be large. So you need to decide wisely about if it's eager, if it's lazy. Yes. Do you know what is the most known issue for lazy loading? Yeah, great. I have a duck for you. It's a simple one. Yes, good job. I have more ducks, so don't be scared to talk. So we'll talk about n+1, and later, on the contrary, I will talk about other problem. So we have a unit of work here. We have loaded employees, and for each employee, we are logging employee get ID and employee get company get name. Okay, so simple logging, but the company is lazy loaded by the employee. And in that case, here, I don't know if I have this on the slide, maybe yes. For that case, it will load one query, it will execute one query, and then for each employee, it will generate another query to get the company here. So the lazy loading is, with lazy loading, it's easy to make n+1 problem. So why n+1? We have one here and n of the employees. So for n employee, we get the company, so n+1. But it can get worse. And another example is if we have, for example, companies. So we gather the list of companies, and then for the companies, we get all the employees. So it's like a bigger problem. Nested queries. Always when you see any nested thing in the review, think twice. Okay. So how to find it? Probably you will find it on production, but if you want earlier, then you need to enable SQL logging. But then you have to search for many very similar queries, but it's boring. Yes, we don't want to chase logs. So we have tools for that. There are few of community's tools. This one is actually for Spring Hibernate. And it depends on tests. So if you don't have tests, you will not use it. But it can mark the places when you have n+1 problem if you have tests. So profit. Also, we have our friend Vlad. Vlad is a Java champion. Maybe you recognize him. And he did very many publications on Hibernate. And also he has a book about it. He blogs very often, so good name to remember. And he did some utils to Hibernate to track such problems. For SQL Alchemy, I found such a thing. So if you use Python and SQL Alchemy, you'll find something like that. For Django, I think there was also something. For .NET, .NET, as I said before, .NET has the lazy loading turned off as the default. I won't say if it's good or not. Maybe it's then more conscious or not. I don't know. I didn't program in that environment. But it's funny that we have problems in Java with lazy loading and .NET doesn't have it. So good thing to compare the technologies sometimes. Okay, how to fix it? So we may need a join fetch clause, so a query that will download the whole entity with nested entities at once. For example, here we have a query that is done on the method, and we have like left join here on the company, and we are fetching the employees. So we are just fetching by join. It has its own problems, but let's go further. Once you are using the joins and we want to have one query, use DTOs, unless they are not read-only, of course. We have something like entity graph API in Java. It's kind of similar to what I saw in .NET documentation. We can generate an entity graph for a company class. We can add that it should fetch employees. And then we create a query with that graph, and we say, let's query everything that should be lazy loaded from the start. And also, we have batch size. Batch size is not like the perfect solution of n+1, because with batch size, we can say, hello, this list should be batched by 10, for example. So once you are querying the employees, let's do it by 10. It's okay to like mitigate some problems of n+1, but at the end of the day, you will have multiple queries anyway. Yes, and the good news from Spring Data, JDBC is a connectivity library for databases in Java Spring, in Java. From 3.2.0 something, we have single query loading. Don't mess it up with SQL, and it will allow us to use some of the methods in the very popular API for loading things without n+1 problem. So we are getting there, guys. Okay. What if I don't have n+1, I use .NET, or I do only eagers? If you have such an entity and you have two collections in it, and they are both fetch typed by eager, what problem can arise here? Do you know it? Sorry, once again? Yes. Do you know how it's called? Okay. Sorry? Yes, Cartesian explosion, Cartesian product. Yeah. Okay, and I'm good at throwing today. Okay. So we have Cartesian explosion. So for these collections, it will generate like all the permutations of the data here. We don't want that. We want some specific data for our use case. How to fix that to not have like the explosion? This is the solution from the Vlad that I told you about. You may remove the bidirectional one-to-many and many-to-one, leave only many-to-one. So that's the thing I said to you before. And you select the parent and then run queries for collection separately. We don't have better solutions yet. So we are fetching the company, and then we are doing two queries for both collections. And that's not a Cartesian product here. Okay. Once more, I will say that you don't need sophisticated mappings to write application. Yes, remember that. Please design it. I know that 1 week of programming can save us 15 minutes of design and so on, but try to think about it. Yes. And as you could see, for all the problems, the solution was SQL. So we are saving ourselves from the tool that was meant to save us from SQL. So yeah. The last thing, I don't know what is the time. Okay, we should finish, but let's try to do it quickly. In transactions, what is important? Optimistic locking. Why optimistic locking? Because it fits the most of the scenarios. So we want to get the data, update it, and see if before the commit it changed on the database, to not lose any updates and to not and to have good concurrent updates. And to enable optimistic locking in Hibernate, we need to have version annotation either on field or on the entity class. Without it, that's interesting, Hibernate will work in last wins manner. So if we have concurrent environment, if we don't have the version, then if I get the data and you get the data, and I push the data and you push the data, you will never know that my update was there. We don't want that. We want to block the second update. That's the optimistic locking, yes. So it looks like that, very simple. And now, when we have that version, when an entity is loaded into the persistence context, so this bug for all the entities in the transaction, the version is incremented once the entity changes, and ORM will check the database before writing the entity. Very simple mechanism. If anything changed, optimistic lock exception will be thrown, and we can do something with that. Do you know DDD aggregates? who knows what is aggregate, what aggregate is. Okay, few of you. Okay, good job. I really encourage you to get to know DDD aggregates, tactical patterns. So with entity annotation, so just entity, with version annotation, so the one from the previous slide, and some business logic that we want to guard, we can model an aggregate. It's simple as that. And additionally, if you are looking for the most, I don't know, perfect solution, if you have an aggregate and it does have some child entities, you want to enable lock mode type optimistic force increment. So whenever any child is updated, then the parent is also updated with new version. That may be very helpful. Okay, so what with the exception, optimistic lock exception, that will be thrown if optimistic lock occurs? You can catch it, and common strategies include retrying the operation, merging the changes, informing the user of the conflict. The last one is the perfect one, I believe, because it's the simplest. Okay. And for last two slides, transactional pitfall. So inside unit of work, yes, inside the transactions, we don't want to pass the entities between the two transactions, okay? They are mostly observed there where they were created. Also, passing managed entities, if we were to do that, may do some ambiguous decisions about what should happen to that entity in what transaction. Yes, we don't want to have that problems. Yes, so another thing, if one transaction with the shared entity fail and other succeeds, then we have inconsistent state. So if you want to pass anything from one transaction to another, use IDs or DTOs, okay? Don't do it with entities. And the last one, do you know what's wrong? I think it's wrong with that code. The last one, the last chance for a duck. Yes, why? No, let's assume it sends SM like mails. Yes. So if we have transaction unit of work, we don't want side effects to occur in them. We don't want any event service to dispatch anything from the transaction, because the transaction can fail, and then it will be rollbacked, and then we have like the previous state of the database, but the event was pushed. So don't do that. Only outside the transactions units of work. Okay. If you have enough of Hibernate and JPA, I'm saying about Java developers now, you can check out a few tools. It's Juke. It's a more lightweight solution for the SQL, for the maintaining the entities and so on, and also for the Spring Data plus JDBC template. I know some people that are using that combo, and it works really well instead of Hibernate, because you don't need to like bother with ORM things. Yes, no dirty checking, no lazy loading, update everything at once, fine-grained control. You can program it as you wish. Question mark. In case of Juke, it was used in DDD by example Cinema project. It was coded by Jakub Pilimon. You can, at the end, I will give you the presentation so you can click that link. Also, you can read here about the differences in times between the JPA, so Hibernate, the full ORM, and JDBC, so only the okay, some wrapper for JDBC from Spring Data. So something that you would use in that combo. And the spoiler is that JDBC is faster, but you know, you don't have dirty chain and so on, so it's fairly normal. Okay, in case of books, this one is very good to have like basic standardized and to know what is under the hood in Hibernate JPA. Also in the Spring Data, in the newest version, it was published this year. And our friend Vlad also wrote a fine book on high performance Java persistence, but it is from 2015, so it's not so up to date. But I recommend personally to observe Vlad because he has very good content. Also, if you don't like reading books, Vlad also doesn't like. He has very good tweets. Then you will have some links here for the 2 blogs. This one is like less technical than the Vlad's, but it's like more user-friendly. I really recommend that one. Here we have the official Hibernate user guide, and it's really user-friendly. I was using it and I understood things, so I do recommend it, actually. Also, I have 2 videos in Polish, actually, for some tips how to avoid pitfalls in the JPA, and also how to treat transactions in JPA. So if you want to know something more about JPA and Hibernate, then this is the good direction. Also, I recommend searching the internet because I hope that I will be able to show that. Yeah, I've Googled a thing about common mistakes in Entity Framework Core, for example. That presentation occurred this year. I've watched it, and it really shows the same type of problems that Hibernate has, but in EF Core. So just use it. Also, I tried to Google for some Django SQL Alchemy problems, and we have something like that in Django ORM problems and so on. If you want to make your ORM more performant, you don't want to get into pitfalls, Google for such things, and it may help you. It's all from me, and I have something for you. This is the survey. If you would like to help me grow, please spend 2 minutes to fill it. And also, there you have contact to me on LinkedIn, and also the presentation. So if you want to get the presentation, you have to go through survey, and then you have only spent 2 minutes on that to help me. So thank you very much, and have a great lunch.